So today we'll be looking at question 1. So today we'll be discussing stationary object or object at equilibrium, or we can say object at rest or object at state of rest. So now, objects that are stationary are objects that are not moving. Just briefly, objects that are not moving, their velocity is 0, their acceleration is 0, and their net force is equals to 0. So basically, in question 1, we're given block A. We're given block A, that block A, which is at rest on a horizontal rough surface, and this object is used as an anchor to hold block B, right? Hence it's not moving, and then it's used an anchor to hold block B with a mass of 56 kgs. Hence we can see here block B is held by block A, and then block B has this mass of 56 kgs, right? So now, and then this object, or this block B, it's in the air at a certain height above the ground. The two blocks are connected with rope R, and as you can see that here we have block R, which connects block A and block B, and then this rope makes the angle 35 degrees. This cable here makes this angle 35 degrees with the vertical axis, and then block B is suspended from the ceiling with cable C, and then we can see that this cable C makes this angle theta from the ceiling, or from the horizontal axis of the ceiling. And then block B, hence we can see from here, block B, it's also stationary, or it's a state of rest too. Hence block A is also not moving, right? And then we can see if block A was moving this direction, if block A was moving this direction, block B will eventually move downwards, will go downwards, go down to the ground. And we are also given that block A experiences a frictional force of magnitude 200 newtons. So we can eventually see that the direction of the frictional force will go to the right hand side. Hence we know that frictional force is defined as the force that opposes the direction of the motion of an object. And we are also given that the system is stationary, or the system is a state of rest, or they can also say the system is at equilibrium. I want you to make use of this word stationary and equilibrium, because there's a concept called equilibrium. So we are talking about stationary objects here, right? So now let's look at the first question. The first question says, define the term resultant vector. So I like this definition. It says that it's a vector that has the same effect as two or more vectors. So it has the same effect as two or more vectors. Let us try and explain this definition. Let's say, for instance, we are given this vector going this direction. We have vector 1 going this direction, and another vector going this direction. We can say this is vector 2, and another vector going this direction as vector 3. And then we can see that the resultant vector of these two, it will be V resultant equals to V1 plus V2 minus V3. So we can see that this resultant vector has the same effect as these vectors here. That's why we are saying that it's a vector that has the same effect as two or more vectors, right? So now they're saying that what is the magnitude of the resultant force acting on block B? So we already told that the system is stationary. Therefore, the resultant force, F resultant, is equals to 0 newtons. Hence, the entire system is 0, acceleration is 0, velocity is 0, right? So now, the next question says that we have to draw a labeled free body diagram indicating all forces acting on block B. So now let's draw a free body diagram of all forces acting on block B. We can see that this is our block B, and then we can see that on block B we have the gravitational force going downwards, which is Fg. We have tension R and tension C. So answering this question, most of the time we have to look at the marks. If we have 3 marks, it means that the free body diagram has to have 3 forces. We have 3 forces here. For 3 marks, we have 3 forces. So now let's go ahead. We can count the forces. We have tension C, tension R, and Fg. Therefore, it's 3 marks. So now let's draw the free body diagram. The other one is going this direction. So this is tension C and tension R, and then Fg, or you can say W for weight, right? Now determine, question 1.4 says that we have to determine the horizontal component of the force in rope R. So now remember here we were given the frictional force, right? We were given this frictional force, the frictional force which was equals to 200 newtons. And then in this side we were given the 56 kgs, the 56 kg. So now we have Fg here, we have tension C, we have tension R, and then I would like us to also draw a free body diagram of block A. So in block A we have frictional force, we have normal force, which is the force that is exerted from the ground going upwards, which is our normal force, and then we also have Fg going downwards from the center of the object. We have Fg, and then we also have tension R here, and then this angle here 35 degrees, and then obviously we'll have alternating angles. Obviously this angle here is going to be 35 degrees. We'll just put the 35 degrees here just to guide us through the process. And then now I would like to remind you guys about components. Remember here we are looking for the horizontal component. So I would like us to use this diagram. So this is for block A and this is for block B, right? So now I would like us to use block A. So I will draw the 2 components for tension R, right? So now cable R, so it will have T cable Rx, the horizontal component, and the vertical component TRY. So now from this, I would like us to also use the angle, this angle here, the horizontal angle, not the vertical one. So remember here we'll have 90 degrees. So in order for us to find this angle, we'll have to say 90 minus 35, which will give us 55 degrees. So we'll have our 55 degrees here. Having our 55 degrees here, we'll eventually know that TRX will be TR cos 55 degrees, and then TRY will be TR sine 55 degrees. And then we are also given that F, the frictional force, is equals to what? 200 Newton. And then in this question we are required to calculate TRX. So now remember this system is stationary. So from here, from F net in the x-axis, so we'll say F net in the x-axis will be equals to 0, since we know that the system is stationary. And then now we know that F net will take to the right as positive, so frictional force will be positive. So we'll have frictional force minus TRX, which is the horizontal component, will be equals to 0. But we already know what is frictional force. Our frictional force is 200 newtons minus TRX, which is equals to 0. So therefore our TRX will be equals to 200 newtons, since you just take the TRX to the right hand side, giving us TRX equals to 200 newtons. So now our horizontal component of rope R will be equals to will be equals to 200 Newton. So that's your 1 mark. So now calculate the vertical component of cable C. So now, instead of using block A now, instead of using block A, we'll now use block B. We'll now use this block here. So now, in this block, I'm going to do components also. I'm going to do for components for cable C. I'm going to say we'll have tension of cable C in the x-axis, and then tension of cable C in the y-axis, and then also I'm going to do components of cable R. We have TRX also, and then we have also TRY. And then now remember, we are looking for the vertical component. We are looking for this component here, and then we have to find 1, 2 in order to find this one. But this one, it's easy to find. We know that Fg is equals to mass times gravitational acceleration, and we already know that our mass is given as 56 kgs. So we'll say 56 times, and then we already know that our gravitational acceleration is 9.8 meters per second squared. So now our Fg will be equals to 56 times 9.8. So punching that on your calculator gives us 548.8 newtons. Since now we are done calculating Fg, our main objective is to now find Try. So now probably you guys are wondering, how will we find Try? So since we already know that Trx is equals to 200 Newton, right? Since we already know that Trx is equals to 200 Newton, it's easy for us to, we already know that another formula of Trx, hence we already know that the component of Trx is equals to Tr, tension of R, cos 55 degrees, right? So we'll use that formula, we'll substitute that formula there. We'll say this is Tr cos 55 degrees equals to 200 Newton, and then we'll divide by cos 55 on both sides. Divide by cos 55 on both sides. Therefore, tension R is equals to 348.69. So we'll write it there. Tension, you can punch that in a calculator. 200 divided by cos of 55 degrees is equals to 348. Rounding it to 2 decimal places gives us 348.69 newtons. Since now we already know what is our tension R, it's easy for us to calculate Try. Now we have to calculate Try, and then we already know that Try is given by the formula Tr sine of 55 degrees, right? So now where there is Tr, you'll substitute the Tr that we found, which was 348.69, to find our Try. So Try will be equals to, Try will be equals to 348.69 sine of 55 degrees, and then you punch that on your calculator. And punching that on your calculator actually gives us Try equals to 285.63. So go ahead and write that down. Try is equals to 285.63 newtons. So now we already found Try and Fg, so now we have to find Tcy. So now we can see that this will be the easy process. This will be our easy process. Let me go ahead and erase this. So now we already know that F net in the y-axis is equals to 0, and in the y-axis we'll take going upwards as positive. So Tcy, which is going upwards, is going to be positive, and then also Try is also going to be positive, but Fg is going to be negative, equals to 0. And then we'll substitute Try, which is 285.63, and Fg, which is 5 48.8 equals to 0, and then we'll put our TCY there, and then you'll punch that on your calculator. Punching that giving us negative 263.17, and then TCY equals to 0. Therefore, TCY is equals to 263.17, since we took the negative 263.17 to the right hand side.